How was everybody's weekend? I didn't see you yesterday. That good, huh? Yeah, great. Cool, wonderful. All right, here's what I need you to do. You should have out two things in front of you. And the two things I want you to have out are your QR code. Remember those ones we did with our constructions, as well as the constructions that you actually needed the compass for. Remember, we actually drew out all those constructions a week or two ago. So it looks something like, I took it out already. No. Looks something like this. So the QR code's on it, and the other thing that you did was like the physical, actual, like construction thing. I need you to have both of those out. And then I need you to have your notebook out because you've got one warm-up question on the board, and the warm-up question on the board looks like one of the questions on the major grade you're going to complete today. So I'm literally giving you the answer to one of them, or how to do it at the very least. So take a moment. You are partitioning a line segment, given the coordinates. So I'm going to give you a moment here to draw that out as a picture, and then we're going to go over it together. So I'll give you a minute or two to get yourselves settled. And we're going to get going.
First question was it says find the distance between
Can you put your mask on for me, please? Thank you. Judge, can you put your mask on for me, please? I'm not going to ask you more than one time. So it should be drawn a picture, the line segment. No what? Well, that's what makes it pretty hard. I like that I see some people drawing a picture for this problem. All right, so the question says, point P partitions directed line segment AB. Given the coordinates, find the ratio that partitions the segment. So it's a little bit different because in the past I've asked you to find the coordinates, right, of like the X or the Y, or I tried to ask you the coordinates of the partition point. This time I'm asking you to find the ratio, which is a little bit different, but we're still going to use the same formula. Who remembers the formula that we use for partitioning? What's the formula? Come on, you know it. Bobo?
middle minus first over last
Minus middle. Good. Equals the ratio. Good. Middle minus first over last minus middle equals the ratio. So at the very least, you should have a picture drawn of a line segment with point P somewhere in the middle. That's partitioning the ratio. Now, which one of those is your first point? What? Your first point. Like which point? A, P, or B? My first point. P is my middle point, and B is my last or my end point. Good. Now, we're going to set up the equation the same way as if we were just doing a regular partition problem, except when we do it, we're not going to have any variables. We're only going to have numbers, and it's actually going to be way, way easier. So I'm just going to look at my x values to start. Okay, so if I'm looking at just my x values, nothing else, and I want to set up my equation to be middle minus first over last minus middle, what am I going to do? What's my ratios, or what are my numbers going to look like? What do you think? -2 minus -4 over
4 minus -2.
Perfect. And now it's just a little bit of algebra, just a little bit of like quick math here. What happens when I've got -2 minus the -4? Change the sign to a positive. What is -2 plus 4? 2. What happens on the bottom with 4 minus -2? Becomes a plus 2. What's 4 plus 2? 6. So my ratio is 2 to 6. But can I reduce that? Yeah. What can I divide them both by? 2. So if I divide them both by 2, make it as small as possible. What's 2 divided by 2? 1. 6 divided by 2 is 3. So my ratio is 1 to 3. I can write it as a fraction, or I can write it with the little colon between it. And that's it. You figured out your ratio. Now we're going to do the y values because it should be the same if I do it correctly. But Miss Masso always likes to check to make sure that she did her math right. So now I'm going to do all of my y values. Yes. That's going to wait. Okay, it's okay. All right. What's going to be my equation for my y values? -2 minus -3 over 1 minus -2. Good. Again, it's just a little bit of math. It should be the same thing because my ratio should be the same partition ratio, right? It should make sense. But I'm just going to check and make sure. -2 minus -3, what happens here? Turns to a positive. What's -2 plus 3? 1. And then 1 minus -2.
3.
Yep, that becomes positive. It becomes 1 over 3. So my ratio is 1 to 3, and they both match, so I know I did it right. So my ratio is 1 to 3. Okay, so in just a moment, we're going to get onto Canvas, and you're going to do a partitioning and construction major grade that's going to be due today. This problem looks exactly like the last problem on the partition problem, or on the partition major grade. So there's only 8 questions on the assignment you're going to do today, and this one looks exactly like question number 8 on today's assignment. Yes, question. I'll talk to you in just a second. All right, now what I need everybody to do is you're going to get yourselves logged into Canvas right now. And we're going to take our major grade here online, a little Canvas practice. So I'm going to give you a moment to log yourselves in. You're going to go into modules, and you're going to go all the way to the bottom of module 2. That's where our page is going to be. Now, if you have already done your partition and constructions major grade, because I actually assigned it on Friday, but if you already did it, that's fantastic. You have the option of completing an optional extra credit assignment, which I hope you choose to do. There are 4 extra credit assignments down there for you guys. So if you need to retake your Chapter 1 or Chapter 2 test, both of those are down there for you. If you would like to do an extra credit assignment that will take the place of a lowest grade, that's what the other 2 extra credit assignments are. If I were you, I'd take advantage of all of them. Okay, but that's only if you are already done with what we're doing today. If you've already done this, you can work on one of those 4. If you're not done with this one, then you're working on it right now. Partition and constructions. All right, so I'm going to walk you through the first question here, and then I'm going to give you the rest of the time to work on the last 7 questions. So in this major grade, there's only 2 things you're going to see in this major grade. Constructions, partitioning, and that's it. The only two things, which is why I asked you to bring out your construction notes. Okay. So I'm going to walk you through the first question, and then I'm going to give you the rest of the time to work on your own. All right. Question number 1 says, is there anybody who needs it on paper first before I get started? Anyone? Okay. Number 1 says, based on the construction below, which statement must be true? Okay. If you look at that picture right there, that is definitely a construction. What am I creating in that picture? So if you look at your notes, there are 6 different types of constructions that we did. It is one of those 6 different types of constructions. So if you're looking there, or maybe you're looking at your paper that looks like this one, you should see something that looks similar to that one on your paper. Which one does it look like? What do you think? Is it an angle or is it a segment in that picture? Am I looking at an angle or am I looking at a line? I'm definitely looking at an angle, right? Angle A, B, C. What am I doing to this angle right here? What is this line BD doing? Where is it located? It's located right in the middle. What do we call something that's in the middle? Cuts an angle in half. Bisect. Very good. So this right here is a picture of an angle bisector. So it's saying if I have this whole angle ABC, I'm going to cut it in half with this angle BD, or this line BD, excuse me. So if I'm cutting the angle in half, right? Here's my whole angle here. A little bit more. Okay, here's my whole angle right here. Let's say my whole angle was 100 degrees. What does that mean each angle would be if I'm cutting it in half now? Each angle would be 50, right? So this small angle is 50 degrees. This small angle is 50 degrees. Right? I'm cutting it in half. That's what bisect means. So I have to find a statement that says these 2 angles are the same. Or I need to find a statement that says this angle is half of the whole thing. Right? Because it's bisected, it's cut in half. So I have to figure out which one of these statements says something that's true. So let's just go through. First one says angle ABD, angle ABD, so that's just that angle right there, is equal to half of angle CBD. Is that true?
Yeah.
CBD right here. So is this green angle half of this blue angle? Are they? Is this number half of this number? No, they're the same. So guess what? Number 1, not. Statement number 2 says angle ABD, ABD, so this green angle over here is equal to angle CBD. CBD, the blue angle. Is that true? Is the green angle equal to the blue angle? Are those 2 the same? Yeah. So guess what? Your answer is statement 2. But let's just check and make sure that none of the other ones are true, just in case. Angle ABD, the green angle, is equal to angle ABC, the whole thing. Is that true? No, definitely not. That's 50. The whole thing is 100. So we know that one's not true. Last one, angle CBD, this one right here, is half of angle ABD. So is this half of this one over here? No, they're the same, right? So number 2 is my right answer. So as you're working through, you have to really say to yourself, first of all, what is the picture a picture of? And then second of all, once I know what it's a picture of, which statement actually makes sense for those problems. Okay. So like when you get onto the second problem there, which I'm not going to walk you through, but as you get onto that second problem, the question says, which geometric principle is used to justify the construction? You have to go, first of all, what is that a picture of? What are those? They're angles on what? What kind of lines are those? Parallel lines. You better look for something that has something to do with two parallel lines. So as you read through and you start seeing a line perpendicular to one, right, you can already go, oh, those aren't the right answers. Right, so you're trying to find ones that make the most sense for each problem. So you're going to take the rest of this time. You're going to finish that up. There's a couple partition problems at the end. So you are going to need probably some paper to do those partition problems. When you are done, you have the option of doing some extra credit problems. Or if you are super happy with your grade, then you can chill out. All right? Questions, comments, or concerns? Does anybody need it on paper? All right, then go ahead and get yourself started, and I'll come around and I'll help you out as you're working through. Yep, give me 1 second.